Let's tackle a part of an A-level question on differentiation from the 2018 Edexcel A-level Mathematics Paper 1. This question has an implicit relation, for which we must prove that the derivative is equal to this. Since we are differentiating an implicit relation, we must use implicit differentiation. Additionally, as you can see, we have an xy term here. For this, we must use the product rule. Here's a quick reminder about the product rule. Assume we have a function, y equals uv. The product rule simply is u into v's derivative plus v into u's derivative. Additionally, since we have terms in functions of y, we will have to use the chain rule for these. Here's how that would work. If we take the derivative of a y function with respect to x, we can rewrite that as the derivative of the y function with respect to y into dy dx. Now, let's go back to the question. We have x squared minus 2xy plus 3y squared equals 50. Let's take the derivative. This is a big equation, so let's deal with each bit individually. First, let's deal with the 3y squared term. For this, we'll have to use the chain rule we just discussed. 3y squared is a function of y. So, the derivative of 3y squared is equal to 3y squared differentiated with respect to y into dy dx. 3y squared differentiated with respect to y is nothing but 6y, and we multiply that by dy dx, so the final derivative comes to 6y dy dx. Now let's tackle the 2xy term. With this, we have a product rule here. 2xy is nothing but 2x into y, so let's use the product rule. We have a uv here, so u equals 2x, v equals y. 2x's derivative, that is 2. And y's derivative, we're going to have to use the chain rule from earlier. When we differentiate y with respect to y, is 1. And we multiply that by dy dx as shown. The derivative is simply 1 dy dx. Now, let's put it all together. Dy dx of 2xy is 2 into y plus 2x into dy dx, which comes down to 2y plus 2x dy dx. Now, let's look at the other two terms in the equation, x squared and 50. The derivatives of these are very simple, 2x and 0. Now, let's plug it all in. Back to our original equation, d dx of x squared minus d dx of 2xy plus d dx of 3y squared equals d dx of 50. Now, we can get all the terms with dy dx into it onto one side, and the rest on the other. And then we can factor out a dy dx and solve for dy dx like this, and with some simple cancelling down, we have reached our final solution, and we have proved that the derivative is in fact equal to this. Thank you.